Okay, so we're gonna discuss and how we can help the decarbonization process gaining in efficiency in the blue hydrogen sector mainly. This is me. I'm a market development manager in the Hannifin division, which is hydraulic and industrial process filtration division, mainly on industrial processes. I've been 25 years in filtration, and I'm driving as much as I can regional and global approaches, coaching, and on application needs and developing the energy markets. Our talk today is articulated around these two main points: the Parker hydrogen approach and our specific activity on filtration and separation, giving access to higher efficiencies in blue hydrogen. The size and global presence of Parker, its market outreach, its portfolio of technologies and engineered solutions for motion and control system, all that contribute to position Parker as a leader in the industry. The corporation is distributed over 6 groups, each having operational divisions level with a specialty. Our Hannifin division deploys solutions and technologies for hydraulic filtration, industrial processes, where I am, and condition monitoring solutions used in both the above. This is almost all for the general Parker info. I will spare to you any market trend and info, but instead let's dive deeper into filtration technologies benefits, helping to increase the efficiency of solvent-based carbon capture processes. In Parker Filtration Group, we address the full hydrogen streamline: H2 production, H2 transportation, H2 point of use and application. At our Hannifin division level, we look mainly at production and transportation, but at industrial process level within the division, my role, my part of the division, we are focusing nowadays mainly on hydrogen production and on the two main ones, namely green one and blue hydrogen productions. Let me try to light the pointer on this one. Boom, that's it. So, as today's talk is about decarbonization and carbon capture, let's look at the available Parker equipment in overall, in our approach to the blue hydrogen segment. Filtration, that you can see the 4 main ones here. Connectors, which my division and group is not dealing with. Instrumentation, same. Printed circuit heat exchangers from a recent acquisition of Megit by Parker. So this one we are not talking today, but I think we will collaborate more and more with them in the coming future. And our industrial process filtration team is specialized in gas solid separation, gas coalescing, these two, liquid solid separation, and liquid adsorption. Ta-da! So what is blue hydrogen about, and where in the process do we act? It's basically a steam methane reforming or autothermal reforming process, followed by an acid gas removal unit for solvent-based carbon capture. In the steam methane reforming process, I will call it SMR to go faster, a desulfurized hydrocarbon feedstock, which can be natural gas, refinery off gas, liquefied petroleum, gas or naphtha, is preheated, mixed with steam, before passing on a catalyst in a top fire reformer to produce hydrogen, H2, carbon monoxide, CO, and carbon dioxide, CO2. Afterwards, in the water gas shift reaction, we convert the CO and the CO and steam are reacted using a metal oxide, which is then less added value catalyst like iron-based, alumina-based, copper-based, to shift to additional H2 and CO2. Once you have H2 and CO2, in the final step of the process called pressure swing adsorption, D, so physical process. In the physical, in the pressure swing adsorption, CO2 and other impurities are removed from the gas stream at different pressure level, leaving essentially pure H2. The CO2 can also be removed through solvent-based absorption process like an amine system, Selexol, etc., etc. So just a quick note on this one, the ATR, orthothermal reforming process, is close to that one. Actually is a partial oxidation process where almost all the CO2 produced ends up in the PSA, pressure swing adsorber, in the tail gas of the PSA. So the overall CO2 recovery is now reaching 98%. Without entering into the details of the reforming and water gas shift sections, because this is not the main topic today, we would like to go to carbon capture. I will speak mainly about 2-3 points about the existing solutions that you saw on the flow sheet. We can see that the filtration separation concept in SMR ATR is similar to the technologies that we use in gas treatment in midstream business. We have liquid solid filters, high flow rates, on the water stream to protect the deamine unit. Then you have gas coalescers with a built-in pre-filtration of solids, so a 2-in-1 solution. So removing solids in the first stage, and then the second stage is coalescing the liquids either from gas feed, from the gas as a fuel for the optimum work of the top fire steam reformer, or preventing carryover of fuel for optimum work of moisture from the PSA, sorry, that could impact the downstream compressor. And then a third type of equipment, gas coalescer, single stage, not twin stage, but single stage in this case, on lower loaded gases like hydrogen head to PSA or to compressor or to hydrogen use. I'm detailing these units later when talking about solvent-based carbon capture side, because we use them there as well. So afterwards, when you review, if you're interested in more details, how these work in the first part of the SMR process, you can revert to the explanation that I'm going to give now. The solvent-based carbon capture, the most commonly found in the is the amine unit. A humid loaded gas, syngas from the water gas shift reaction, CO2 plus H2, enters the bottom of a contact tower called absorber with a B, it's a chemical reaction, and contacts countercurrent, an amine flowing downwards that absorbs or selects chemically the CO2. The CO2-rich stream is then treated to remove hydrocarbons and solids, pipe scale, etc., before CO2 can be stripped, desorbed from the amine, dehydrated, and compressed for storage and usage. While on what is now the lean amine side, loops back to the top of the absorber tower. As you can see, the lean amine side is going on the top of the absorber, sorry, here, boom. A correct filtration separation coalescing solution applied at the right spot helps protect your assets, such as heat exchangers, the columns, the reboilers, the compressors downstream, enables higher selectivity of the amine. So basically in this stage, decrease the amine makeup. If you lose amine or you need to change the amine makeup on the top, decrease maintenance overall, and results in lower operational cost. In a simplified view, the main 4 equipment are gas coalescer. So I will speak about, I will detail that one, the Gemini, a gas coalescer with a built-in pre-filtration of solids, as I was explaining, removing solids on the first stage and second stage coalescing the liquids. What from? From the humid gas and loaded syngas CO2 plus H2 from the water gas shift reaction entering the bottom of the contact tower. and on the gas after the stripper and condenser to protect the compressor from liquid and solids carryover. This is the body that we see here, number 1. Second type, gas coalesce, single stage, so the simpler one, on lower loaded gases, leaving the top of the absorber, and the other one at the end of the process after the compressor on gas leaving the compressor to prevent loop carryover. Then I will speak about the number 4 before the number 3. Number 4 is carbon adsorber unit to remove hydrocarbons present in the amine loop, and that facilitates the foaming of the amine, so which decrease the selectivity of the amine. So we place in refinery, we place very often on the rich side, I would say on gas treatment, and here in this case in CO2 removal, we would apply the adsorption on either, depending on the case, either on lean or on the rich, depending on the load of the hydrocarbon present in. But this one, carbon adsorber, must be protected by a particulate material filter, a liquid solid filter, high flow rates most of the time. On the rich side, to protect the heat exchanger, stripper, and reboiler. Okay, heat exchanger, stripper, and reboiler. And on the lean amine side, to protect the carbon adsorber, as the solids, as I mentioned, are always generated at each step in the amine loop, and we need to protect the carbon adsorber from any particulate ingression. The first one, so you will have afterwards some numbers so that you can refer to the sketch very easily. Remove of solid particulate and liquid slugs from the feed gas, as we mentioned, and from the gas after the stripper and before the compressor. The incoming gas is impacted. Actually, in this one, the incoming gas is impacted on the risers tubes, and the humid loaded gas is, you could say, it's knocked out already, collecting some dirty liquid down the sump tank, the first part of the sump tank, because the sump tank is here divided in 2. The first stage removal is going from out to in, is filtration from solids, collecting the solids on the outer layer. The clean humid gas is moving inside the element. You have an element here. It's moving inside the element, going on the second section of the element. And in the second stage, liquid is removed by coalescence from in to out. The liquids flowing in each cylindrical impingement baffle. You see a baffle here that's actually driving the liquids towards the end to avoid the liquid that is coalesced from one element to impact the next element and to load the other element. So we drive the liquids until the end, and then we get rid of the liquids at the end. We drain them out, and we collect them in the second sump tank side, which is a cleaner one. The pH medium that we use in this case is what is shown a little bit here, is a depth medium in polypropylene in this case for amine compatibility, that has a unique helical medium assembly pattern, as you can see here, providing the best area use as it forces the gas streams to follow radial, axial, and the helical movement around the element. It achieves 0.1 micron and larger droplets with a 99.98 efficiency, and 0.3 micron with 99.9 efficiency solids, going lower than 2 parts per billion liquid in weight in the downstream effluent. It removes 28 times more liquid loading compared to a standard single-stage reverse flow coalescer, because of the size, because of the filtration area, because of the medium, because of the time that we leave to the gas inside the pipe and inside the element to easily coalesce. So no secret, that technology is much more efficient. It's for higher slugs liquids. As opposed to that one, on the gas contact tower top up, as well as downstream of a compressor, the gas is loaded with lower mist liquids, I would say, in the gas. So lower loaded gases. The incoming gas flows in, gets inside, so it's already knocked out partially. It goes inside the elements. The incoming gas flows from in to out, and the liquid is coalesced on the outer layer. And when the coalescence, so the growth of droplets, reaches the outer layer, which is a thick medium, depth medium, as we mentioned, the same medium as the pH medium as we saw in the former element. So when the droplets become big enough, then they fall by gravity in this part on the riser, and then they are drained out after a while. The dry gas leaves over a baffle. So you see here a system, they leave over the baffle out to the exit. The elements used are made, as I mentioned, in the same pH polypropylene amine business. If you use polyester, you will have a problem of swelling due to compatibility. So achieving 0.1 micron and larger droplets with 99.98% efficiency. And this one has a fancy name of Spartan, and coalescing is most of the time, all the time, going from into out, reverse flow. Liquid particulate filter removal, so solids from a liquid stream. On the rich side, to protect the heat exchanger, the stripper, and the reboiler. On the lean side, to protect the carbon absorber, as solids are always generated at each step in the amine loop, as mentioned earlier. The flow is from in to out. So normally all filtration in normal elements, which are 2.5 inches diameter, standard size element, are always out to in, because we always tend to use the highest filtration area, which is at the periphery of the element for filtration. Exception, high flows. Why? Because in these elements, we can pleat the elements. So we increase the filtration area, and it's easier to remove solids with a big, without having a big delta P. It's easier to remove solids on a liquid solid separator on a high flow, which is a 6-inch diameter OD element on length like 40 inches, 60 inches. They are inserted in baskets. So they are pleated, inserted in baskets. The baskets are welded in the element separation plate, and we have an element inserted, and you have a chevron seal gasket patented, ensuring a perfect sealing. The element is easily assembled, disassembled in just one movement. You have a handle, it's easily removed, especially in high flow configurations where we position these horizontally. A wide variety of material is available in the amine loop. The polypropylene is recommended. And in terms of rating for solids, recommendation is going around 20 micron or lower. And you will see in some other application in green hydrogen, we go much lower than that, 5-10 micron. In this case, we just want to protect the carbon absorber from any particulate penetration. Number 4, the carbon absorber itself. It can be a fixed bed. It can be in form of a canister. So you have two configuration: fixed bed well carbon for mainly on higher flows, such as on the rich side, or in canisters for easier maintenance when you go on the slipstream, like on the lean side. So slipstream can be 20, 25, 30, 35%, more or less on the lean side. Then we use canisters. This can be sometimes maintenance intensive, depending on how you protect them, but you need to protect them with a particulate filter. We came with our solution to save capital cost and footprint. The liquid filter and the carbon absorber can be combined in one unit, which is called our Extreme Zorb. So again, same as in the coalescence, we use here first stage a pH depth polypropylene medium for solids removal and protection of the carbon absorber. So I need to mention the oleophilic nature of the pH itself attracts larger hydrocarbon and semi-solids and decrease loading on the carbon block itself. So it's already attracting a part of it. And then second stage is the carbon block, and the carbon block itself is not a loose carbon like in a fixed bed or like in a canister. So it's compacted, specifically designed for removal of longer chain heavy hydrocarbon. Innovative structure, so preventing carbon movement and channeling because it's compacted. It yields higher level of mass transfer kinetics, resulting in a smaller footprint. So the porosity itself of the carbon that is assembled, first of all, it's a much smaller powder. Second, it's much higher porosity, easier to compact, and much more open contact area. It's a single pass purification through the block provides 6% higher performance compared to a bed. A bed is 93%, and we go to 99%, so 6% more compared to a multipass in granular. It eliminates the need for a downstream particulate filtration. Since this one is a block, there is no carryover of carbon particulate material. And it's mainly advised on the rich side on the full flow. The 2-in-1 solution is of higher absorption efficiency in summary, smaller footprint, decreasing change-out times by more than 50%, lighter and faster in maintenance, and no need for backflush and downstream filters. And that also already summarizes the speech of today. So Parker Filtration Group, high fee division, industrial process, we deploy proven technologies that we use already in refining business, in midstream gas transportation business, in other very similar businesses. Media efficiencies and capacities are technologies that we provide. New type of media that are not existing anywhere else, so innovative solutions and designs like the Gemini, like the Extreme Zorb. In the view of decreasing footprints, increase cycle times, decrease maintenances, protect mainly your downstream equipment, and increase your plant availabilities. And I'm open, and I will switch to the other panel, to the other screen, if you have any question. In any case, you have my contact details. You can take note. After the session, you will be able to contact Pernilla as well and get our details if you miss this one, to raise questions afterwards and offline, and get back to me when you need.